Hi, this is Algebra 1, Module 5, Lesson 2, Practice Problems. Let's go ahead and practice finding solutions to equations. So it says, identify which of the group given points are solutions to the following linear equation. So it could be more than one. So let's go ahead and let's try all these points in our equation. So to start with, we're going to put in a 3 times 2, since my x is 2 right here, plus 2 times 4, since that's my y. And I need it to equal 12. So let's see what this equals. 6 plus 8 equals 14. So that means this one is a no. Okay, let's try the next one. All right, let's scoot that one up to be under here. Okay, so now I'm going to do 3 times. What happened to my text box? Okay, so we're going to do 3 times 3, because that's my x this time, plus 2 times 2, and that equals 9 plus 4 is 13. Oh, that does not satisfy our equation because we need it to equal 12. Go ahead and mark that one. It's not working. All right, next one. 3 times 4 this time plus 2 times 0. That should equal 3 times 4 is 12 plus 0 is 12. All right, that one works. So I can go ahead and mark this one as a good one. Let's test our last one. 3 times 10. 3 times 0 plus 6. 2 times 6, be consistent. And so 0 plus 12 equals 12. So we had 2 in this case. That worked. C and D. All right, let's try number 2. 5x minus y equals 10. All right, let's do these guys. So first one, 5, 5 times 2 minus 0 equals, well, 10 minus 0 is 10. So A works in this case. Okay, next, let's type in 5 times 3 minus 0. Well, 5 times 2 minus 0 equal 10, and 5 times 3 is probably not. And we are right in that. That one is 15. So that one does not work. Cross him off. Next, we have 0 and negative 10. So 5 times 0 minus negative 10 equals, well, 5 times 0 is 0. 0 minus a negative is actually plus. So 0 plus 10 is 10. So C works in this case. Circle C. And let's try D. 5 times 1 minus 1 equals, well, that's 5 minus 1 is 4. So that one does not work. So I'm going to go ahead and cross that off. All right, so A and C were the only two that worked in this case. All right, let's try this one. Negative x plus 6y. Let's go ahead and put a purple on this guy. All right, so a negative 4 plus 6 times 1. That equals, so that'd be actually double negative is positive. So 4 plus 6 equals 10. I think that's what we wanted, right? Yep. Okay, so let's go ahead and circle A. Let's try B. B is negative 22. Another double negative there. plus 6 times a negative 2. So negative 22, negative 22. So that's positive 22. 22 plus a negative 12. 22 minus 12 would be 10. So B actually works also. Go ahead and mark that. B works as well. All right, next 2 and 2. All right, so negative 2 plus 6 times 2 equals negative 2 plus 12 would be a positive 10. Look at that. We're on a roll with this guy. We have 3 that work so far. Ah, something happened. Zoom back in a little bit. Okay, to 50. That works well. Okay, and so C works. Let's see if D, do we have all of them work on this one? Okay, so negative 10 plus 6 times 0 equals negative 10 plus 0 would actually be a negative 10. So D does not work in this case. So here we had 3 solutions and one that did not. All right, find the value that will make each ordered pair be a solution to that given equation. Well, 2 plus what equals 6? 2 plus 4 equals 6. So that one worked out pretty well since we're just adding the two together. So 0 plus 6 equals 6. And then something plus 0 equals 6. Well, 6 plus 0 equals 6. So we're just adding those 2 points together and they need to equal 6. That one worked pretty well. This one's a little more complicated. So I'm just going to type off to the side what we've got going on here. So 2 times 2 plus 4y equals 8. So here we've got 4 plus 4y. Go ahead and subtract the 4. So 8 minus 4 is 4. 4 times what equals 4? 4 times 1. So that answer must be 1. So we basically have 4, 2 times 2, plus 4 times 1. That's 4 plus 4 is 8. All right, 0. If this equals 0, then 4 times what equals 8? Well, 4 times 2. Just put the 2. 4 times 2 is 8. Here, if I put the 0 here, then 2 times what equals 8? 2 times 4 equals 8. So those zeros make it a little bit easier to solve, doesn't it? All right, the last one. Here, let's type this one out too. Because we got that 2 in there. So 3 times 2 minus y equals 8. So 6 minus what equals 8? Well, if I have a positive and I'm trying to get bigger with subtraction, that means I have to have a negative. So 6 is 2 away from 8, so it must be a negative 2. 6 minus a negative 2 would be a plus 2, so that's 8. So now 3x is 0. 0 minus 8 equals 8. Well, negative double negative, so I need to have a negative 8 for this one. 0 minus a negative 8 would get me a positive 8. And here, if I'm subtracting 0, 3 times what gets me 8? Well, that one's a little bit trickier. I'm going to go ahead and type it over here. 3x equals 8, because we know this is a minus 0, so that's out of there. I would have to actually divide both sides by 3, which would give me 8 over 3. So we'll just go ahead and keep it as the fraction, because that way we don't worry about decimals and rounding, because that 1/3 or 2/3 would be repetitive. All right, so there we go. Graphing linear equalities. I'll zoom in just a tad more because it is harder to do these when I'm zoomed out. All right, so graph the following inequalities on the coordinate plane. Name a point that is a solution to your inequality and a point that is not. Then we need to show algebraically and graphically that your points are correct. So if I'm going to solve this for, oh, I don't have to solve it for y. It's already solved for y. So I just need to graph this on my graph. So I'm going to go ahead and do my line here. So we're going to assume these are counting by one. So 1, 2, 3, 4, 5, 6, 7. So there's 8. So I'm going to start at 4 because that's my y-intercept, right? So 1, 2, 3, 4. Use my cursor. 1, 2, 3, 4. And I need to go up 3 over 1. That's actually all the farther. Well, I guess we'll kind of straighten it out here. There. And let's go the other direction. So start at 4 and down 3 over 1, down 3 over 1, down 3 over 1, down 3 over, so about right here would be straight across. Okay, so y is less than or equal to, which means I need to do the y's that are less than. So I'm going to put all this just shaded in. Okay, so now it says I need a point that is a solution. So I see 0, 0 is inside my shaded part. So I'm going to do 0, 0, 0, comma 0. You can use any point that's in that shaded area. And so if I were to go ahead and fill that in, 0, oh, I'm going to do my equation thing here. So 0, blue, 0 is less than or equal to 3 times 0 plus 4. Well, that means 0 is less than 4, so that's true. Okay, let's go ahead and pick a point that is not in there. Oh, you know what? I should have done those in purple. Get that one back. We have, here we go. Let's do him in purple. See if it lets me, let me highlight it since I did all the others in purple. Nope, it doesn't want me to change it. All right, so we'll change our drawing one to blue. Let's go ahead and put our 0, 0 at blue. Okay, it's hard to see inside that green. All right, so we'll take our purple then, and we'll pick a point outside of it. So I'm going to do 1, 2, negative 3, 0. Let's go ahead and do negative 3, 0 is our non-solution. And that one would look like here. So again, a 0 as our y is less than or equal to 3 times, there are 2 of them, 3 times negative 3 is 4. That's negative 9 plus 4, and that'd be negative 5. And so that is not true. So we have our true solution and our, let's just go ahead and mark that, true solution and not true. All right, our false solution. Okay, so I'm going to go ahead and do, I guess I'll do 8. We'll do it in order. Okay, so for here, let's go ahead and do, I'm going to do yellow for my line because then it's easier to shade in and see. Okay, so y is less than 7x minus 2. So I'm going to go down to negative 2, and then I have to go up 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Oh my goodness, I forgot to do my line. Just drew. Did a pretty straight line though, gotta admit. Let's do the yellow here. All right, try that again. 2. 1, 2, 3, 4, 5, 6, 7 over, wait a minute, 1, 2, 3, 4, 6, 7 over 1. So I'm going to go ahead and put a mark here because it's going to be hard to count when I don't have 7 boxes to go by. So we're just going to try to straighten that out here. All right, now this one I'm going to go opposite. 1, 2, 3, 4, 5, 6. Is 7 down here? I don't want to go too far. Try to make that as straight as possible and still get to my, okay, something like that. Y is less than. So I actually want to fill in my less thans over here because this is where y is less than, but it cannot be equal to. So here's part of the problem. I'm actually going to, I don't know if I can do this with here. I'm going to go ahead and just put little breaks in here because I want to show it is not equal to it, but that's where my line is. All right, so blue is our solution. Let's go ahead and do our blue text box. So blue is a solution. Let's do this time. I like to use something on the line because that makes it easy to work with. I'm going to do 2 comma 0. So let's do 2 comma 0. Makes it easy for us to be able to compare it. So we want, actually I don't have to use my equation for this one. We can just keep going in here because we have a less, what did I just do? Lost my page. Here we go. Go back to this guy. All right. So we're going to do 0 is less than 7 times 2 minus 2. Well, 14 minus 2 is 12. 12 is greater than 0, so that one works. Now let's find a spot on there that is not a solution. So in this case, 0, 0 should not be a solution, right? Because we did not go through it. So let's try 0, 0 as our non-solution. 0 comma 0. So is 0 less than 7 times 0 minus 2? 0 minus 2 is a negative 2. That is not bigger than 0. That is less than 0. So we are correct. This one is false, and this one is true. All right, let's go over here to 9. All right, I'm going to do my line in that yellow again. So here we have a greater than. So the same idea as what we did before. I'm going to do that dotted line thing, but first I'm just going to get the line on there. So I'm going to go to positive 2, 1, 2, and I'm going to go down 3, right 5. 1, 2, oh, I'm drawing again. I get that shape. So much easier with the lines. Okay. 1, 2. I'm going to go 1, 2, 3, right? I started a little bit high. Let me, no, a little low. There we go. 1, 2, 3. And now I need to go over 5. 1, 2, 3, 4, 5. Down 2, 3. Over 1, 2, 3, 4. And that'd be about right there. Okay. So I'm going to go the other direction. 1, 2, 3. 1, 2, 3, 4, 5. And 1, 2, 3. 1, 2, 3, 4. That'd be about right there. So that's pretty good about showing my line. Okay, now my shaded part is greater than, so I want to do the side that is above that line, because that's where my y's are greater. Okay, so point that works. Let's see. Let's do 5 comma 0. 1, 2, 3, 4, 5. Here, right here. 5 comma 0. And put that over here. So 5 and purple. These are the ones that work. 5 comma 0. And so I'm 5. There we go. Now that looks right. Okay. So let's say our x. So it's negative 3/5 times 0, right? Plus 2. So 5 has to be greater than. All right. So is 5 greater than 0 plus 2? Yes, 5 is greater than 2. All right. Let's try another spot. Let's do, well, 0, 0. Oh, I changed my color on my other ones. Okay, 0, 0 is not in my solution. So it's not, is it going to change my color? There we go. All right. 0, 0 is not in the solution. So let's go ahead and do 0, 0. So is 0 greater than negative 3/5 and 0 plus 2? Notice we kept the same x value on here. We did zeros. So 0 plus 2 is 2 less than 0. It is not. So we have false for this guy, true for this guy. All right, last one. Y is greater than negative 6. So, oh, I forgot to dot this line. Because it's greater than, we cannot say it's equal, so that has to be dotted. All right, so over here, y is greater than or equal to negative 6. 1, 2, 3, 4, 5, 6. So 1 from the bottom, right? 1, 2, 6. So it doesn't matter what x is. Y is negative 6, right? So it's aligned this way. Y is greater than that, then it's everything up here. Greater than or equal to. It's the whole graph up there. Okay, let's find a point that is in our solution. Well, in this case, 0, 0 is. So I sure like it when 0, 0 is in there. It makes it easy for our work. 0, comma 0. Equation this time. So we have 0 is greater than or equal to negative 6. Oh, that is true. 0 is greater than or equal to negative 6. How about a non-solution? Down to, let me draw. Let's go down to 0, negative 7. Go ahead and try that one. 0, negative 7. So what that one says is, so this one is saying x is 0, but y is negative 7. So negative 7 is greater than or equal to negative 6. Is that true? It is not. So we have our false one here and our true one here. All right, let's keep going. Follow the directions for each problem below. Zoom that back out just a tad. Solve for x and then graph slumber line. Okay, so let's go ahead and do 10 minus 3x is less than, not equal to, just less than 28. Well, first I'm going to subtract 10, subtract 10. Those cancel. Negative 3x is less than 28, that's be 18. So divided by -3, divided by -3, those cancel. X, I have to flip my sign, is greater than -6. So I'm going to put a 0 here, 5, -5, and it's an open circle because it's not equal to, and it is greater than. So I'm going to go this direction. So x is greater than -6. So let's select an x value from our graph to put into the inequality, and we're going to solve it to see if it actually works. So let's pick 5, right? X 5 is greater than -6. So 10 minus 3 times 5, is that less than 28? Well, scoot it over here a little bit. 10 minus 15, that less than 28? Yes. -5 is less than 28. So we've just kind of proved, yes, yes, it holds true. So we did need to flip our sign. Select an x value that is outside of the solution set of your graph. Replace x in the original and solve. Okay, so let's do -10. So 10 minus 3 times -10, is that less than 28? Well, 10 minus a -30, that less than, oh no, don't do that, less than 28. Well, minus a negative is actually plus a positive, so 40 less than 28. So yes, it shouldn't be true because it is outside the solution set. All right, 12. We're going to solve for y, and then we're going to use an equal sign instead of a greater than or less than. So I'm going to go ahead and do that over here, maybe down below. So 4x minus 2y is greater than or equal to 6. Scoot this down just a tad and try to draw it down here. I don't want to run into that questions line. So 4x minus 2y is greater than or equal to 6. And I need to solve for y. So let's go ahead and minus 4x minus 4x. I'm going to put it in slope-intercept form so that I can solve it, graph it easier. -4x plus 6 divided by -2, everything. Y, got to flip my sign because of the negative. 2x minus 3. So let me do this down here. Y is less than or equal to 2x minus 3. Okay, here we go. Now I can, y is less than or equal to 2x minus 3. Rewrite your inequality as an equation. And so let's get rid of the inequality. Y equals 2x minus 3. And we need to graph the line that goes with the equation. So -3, 1, 2, 3. And then I want to go up 2 over, I'm doing a great job with my lines right now, but I need to have my diagonals. Up, so -3, up 2 over 1, up 2 over 1. I don't think these are equal sized boxes. That makes this a little bit tricky. 2, 2, 2, 2. Okay, and then we'll go up this way, halfway through there. All right, and we'll go down the other direction. Down 2, right? Yep. And then down 2. Okay. So our boxes are not perfectly even, which throws this off a tad, but not too bad. Okay, graph the line. We did that. Name the y-intercept. it is -3, because we know that from right here. Our slope is 2 because it's slope-intercept form. Select a point that is above the line. Let's do 0, 0. We like that one, right? 0, 0. Replace the x and y value and see if it still works. So 4 times 0 minus 2 times 0, is that greater than or equal to 6? No, that is not true, but we picked a point that wasn't true. So yes, actually, let me type that. Yes, we picked, picked a point above out of the solution set. Okay, select a point that is below the line, which is what we wanted, right? Less than or equal to. So let's do 1, 2, 3, 4, 5. So 0, 5. 0, 5. So let's replace that in our equality. 4 times 0 minus 2 times 5. Is that greater than or equal to 6? Hmm. Did I do that one right? 0. Oh, -5. There we go. I was like, that should work. So 0 minus a -10, which would be plus 10. 10 is greater than or equal to 6. So does it still hold true? Yes. We picked a point in our solution set. Explain which side of the line should be shaded. Below the line should be shaded because y is less than or in these or quotations. We want it less than or equal to, so it should be lower than the line. Decide whether the line should be solid or dotted. Well, in this case, it should be, the line should be solid because can be equal y. Y can equal the equation. So now we got to determine between dotted lines and not dotted lines. All right, that's it. Thanks for joining us. See you next time.